Time to do some math. Isaac, happy birthday, my dude.
Happy birthday to you. Happy birthday to you. Happy birthday to you. Happy birthday to Isaac. Happy birthday to you.
He looks amused.
Happy birthday to you. I said Joey. Yeah, you look good.
You guys seem wound up today, so I figured that was a way to get you in. Time to do some math. And then, if we get through the lesson in a decent amount of time, you should have time to do homework at the end of this. Okay, so what should everybody have out right now? Graph paper. Now you need to pass back your test. So if I make it to 9:40 and I have yet to we have yet to get through the lesson, pass back your test, I gotta do it then. So they're still not in math because I forgot to pass them back yesterday. So we need to take care of that. So today's lesson is 2.2.4. It is repeated addition as multiplication or vice versa, which means turn that phrase around. So multiplication is a shortcut. And as with everything, bless you, in mathematics, we made it up. That's one of the coolest things I like about mathematics. By the way, graph paper moved. I moved it because it's awkward when I sit there a lot and graph paper was behind me. So it's more towards the corner. And I put the lamp on the table for all of you very observant people. This room is really tall. So it really works better outside. Our style at home doesn't really match that anymore, so those lamps have been retired. So one of the cool things I like about mathematics is we made it all up. Now let that sink in for me. Mathematics is all completely made up. It's not bogus. Now, so what I was just talking about with some of your classmates, hey, why do I have people talking at the same time as me? If you would like to talk, right, at the same time as me, go somewhere else. Love you guys. I want you in my classroom, but I don't want to fight with a 7th grader for who's talking. If I'm trying to teach, you're not talking. Otherwise, there's no door blocking you. Peace. See you later. AO extensions, whatever. No joke. Figure it out. So what I was talking, Mr. Estes came to me this morning, and he was all excited. He's like, hey, did you hear about this? I was like, no, man, I haven't heard about this. So I think he's 74 years old. A mathematician, what's his name? Michael Attia, believes that he has solved one of these 6 unsolvable, and they're not really unsolvable, just no one has solved them yet, problems in math called the Riemann hypothesis. And if true, if his solution is valid, he gets $1 million prize.
What?
So these questions were made up, not really made up, but they were thought of or articulated by mathematicians a long time ago. It was actually, his name was Riemann. His last name was Riemann. So you can read about this if you want to look it up. If you search the Riemann hypothesis, R-I-E-M-A-N-N, you can read more about this. There are 6 different questions, but yeah, if his proof is true, he wins $1 million. Now, on that note, what he did was figure out something other people hadn't figured out yet. So what we're going to do today is a technique that for a long time people hadn't figured out. Yeah.
How are they going to see if he's true or not?
They check all his math. They bring in a bunch of teachers, but mathematicians, and they check his work.
But if no one has ever solved it before, how are they going to check it?
They can check if what he said is true. So all because they couldn't figure out the solution doesn't mean that they can't check if what he said is true. Because there are certain rules, certain properties, certain things you can and cannot do in mathematics that are just no. We know these rules and all it's the utilization of them to solve those super complex problems that no one was able to do. Now, this guy obviously was like has been in math for a long time, so his brain is used to like trying to think about problems in different ways. So I mean, and we don't know if he did it right or not. It hasn't been checked yet. He just 2 days ago presented, "Hey, I think I solved this problem." Yeah, but there are still at least 5 of those out there that you could win $1 million for solving that math problem, and any of you guys could do it. Like it could be you. You could be the next one. So multiplication, kind of like the Riemann hypothesis, where somebody just like figured it out. Multiplication is a shortcut to repeating addition. So instead of saying 7 plus 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 negative 5 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 plus negative 5, we have a quicker way to do that, right? And unless you really like hearing me like in repetition, you probably don't want us to deal with problems spread out like that with addition. So instead, we created, like literally mathematicians at some point created multiplication. So if you don't have a header yet, we are on 2.2.4. Multiplication saves the day. That's my header. Multiplication saves the day. Aiden, this is how you get ants. You know how you get ants? That's how you get ants.
I know, but I dropped it and I'll pick it up.
Alright. So, how many 7s do we have there? 1, 2, 3, 4, 5, 6, 7, 8 7s. It's kind of funny. So, instead of saying 7 plus 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 7, what can I say instead?
7 times 8.
Eva?
7 times 8.
Yeah, now I'm going to say 8 7s. It doesn't matter whether you say 7 times 8 or 8 times 7, so please write that down. And this means there are 8 of the number 7, right? And plus, and we have, and always means plus. So I'll write this down here too, so it's a little bit easier to read. How many negative 5s? 8 negative 5. Double check. 1, 2, 4, 5, 6, 7, 8. So you should have this on your paper as well as a header. So what is 8 times 7?
56.
That's a really fun one, yeah. 8, 7, 5, 6, like 5, 6 is 7 times 8. The numbers kind of like work together in a sequence. So this is 56 plus, what's 8 times 5? Forget about the negative for a moment. 40, then make sure you involve the negative in your answer. Then who wins our battle, quote unquote, the positive or the negative? The positive by how much? 16. Any questions on why we would use multiplication or how that works? Adrian? Yeah, comment. Hit me with it.
I feel like we could have just taken 7 and then subtract 5 and then multiply that by 8.
Ah, so Adrian has an idea that he thinks instead of doing what we just did, capture this, we could instead say we have 8 sets of 7 and negative 5. Now what's 7 plus a negative 5? What does this give us? 2. What's 8 times 2? 16. Do we get the same answer?
Yeah.
So does that work? Adrian, try to solve the other 5 Riemann problems. You'll get $1 million. I mean, you figured out this, right? So, now, here's my opposition with what Adrian just said. When I see this, I really think that was 7 plus negative 5. 7 plus 7 plus negative 5 plus 7 plus negative 5 plus 7 plus negative 5 plus 7 plus negative. Like, that makes me feel like they were grouped as 7 and negative 5. They weren't, but could we rearrange addition and group them? 7 plus negative 5 plus 7. Yeah, we can rearrange addition because that commutative property. So regardless of this having the same answer and obviously working, we could change the addition order and make this happen. Very astute observation. Okay, come on. All right, so with your team, agree on how to re-represent what we have shown in 68 and 69 using multiplication techniques. Yeah, this is a quicker lesson. Sorry, I'm moving too fast. I scrolled and I skipped over.
So if there is anyone remaining that needs to get a picture, please come to the area across from the office. Thank you.
So you had a problem like this on your homework. I think you used the numbers 5, 6, 7. We need to get to a distance of 6 total feet. So this is a span of 6 feet. But the only moves we're allowed to use are moves of 5 and 8. So I want you guys to figure out, and with your group, and then like once you get done with this, then you can move on to 68, 69. With your group, figure out at least 2 ways using 5 and 8 to end up at 6. Now remember, we can go either direction, forward or backwards, and we can do the moves as many times as we want. So figure this out, then I'll take some solutions up here. If you get done with 67, your group agrees, move on to 68, 69. You gotta do at least 2 ways. Yeah, 2 different. One's easy. The first way, like, you can only use 5 and 8. But you can do it as many times as you want. What's up? Oh yeah, you can use them as many times as you want. You can use them 3 times, 4 times, 8 times.
No, like can we use them like 8 plus 5 is 5 plus 8?
Yeah. Yeah, you can use either of them, positive or negative, as much as you want.
I was gonna say another 8.
Wait, hold on. You said 8 minus. No, no, wait. And then you have to go 8. So 8 times 2 minus 5 times 2. And minus 6 times 3.
So in walking around, Eva had a really good idea. Eva wrote out the move of an 8 and a negative 5 or a minus 5, right? If I go 8 forwards and then 5 backwards, how far does that end up moving me? 3. So if I do that, and then I add another 8 and add another negative 5, that's going to move me 6 total. So if I move 8 forwards, 5 backwards, 8 forwards, 5 backwards, I get that. You got another one?
5 times 6 minus.
Ooh, we cannot. Well, okay, so you're saying like 5 plus 5 plus.
Plus 5 plus 5.
Okay, so I can rewrite that as 6 moves of 5. And then.
Plus 8 times 3. I mean, minus 8 times 3.
So a negative 8.
Yeah, negative. Plus negative 8. Plus negative 8.
Oh, I did a really, really long.
So 3 times negative 8.
5 plus 1.
So here we have 6 moves of 5. And then 3 moves of 8 in the opposite direction. Right, back. How far does 6 moves of 5 take me? 30. Right, how far do 3 moves of 8 take me? 24, but the opposite direction. Do I end up at 6? Yeah. So there are actually infinitely many ways to do this. You can do this all day long, all night. There are infinitely many ways to do this. This is fairly straightforward, but move on to 68, 69. I'll give you like a minute for those.
A minute?
Yeah, you don't need longer. of course you move on to 70, right? You're stuck on 68?
Yeah, I don't understand.
So, what does he do? Explain to me what he does. He does 6 4 times.
Yeah, it's 24.
You're not confused. So, all we need to write there then. So Joey lied to me. Right? He stopped me and he said, I'm confused, but he's not. He's just lying. So, because then I asked him, I said, well, what did he do? What did Cecil do? And Joey said, well, he moved 6 4 times. I was like, dude, you just told me what to do. He's like, yeah, you get 24. Yeah, you're a liar. So, he just said, I moved 6 4 times. Or we could say 4 times the move of 6.
Or you could say
Either
6
way.
plus 6 plus 6 plus 6.
And nobody
That's
wants
it.
to do that.
So, since it says do both ways, now we could argue we have 2 different ways here, but actually this multiplication is essentially the same.
You can do 12
But it's
times
different.
So, as we could do 12 times 2, if we merge the 6 moves together. We could do 6 plus 6 plus 6 plus 6. We can actually do this more than 2 ways. It says show both, but there's more than that. But yeah, this whole 6 times 4 or 4 times 6, guys, I really encourage you, get comfortable using parentheses. The dot is great. Like the multiplication dot is great. But honestly, that, when you're writing fast, can very quickly turn into that, which very quickly looks like that, which before you know it gets read like a decimal accidentally, as opposed to the multiplication. A number right up against another number in parentheses, regardless if it's positive or negative, always means multiply.
It's all the math.
So I encourage you to get comfortable with that parenthesis multiplication technique. So in 69, let's use some cards today. Natalie, what can we write to write 69 a bit easier?
Wait, 6 and 4?
Sorry, 69.
Oh, yeah.
The
okay.
next problem.
You can do 4 times 5, or like whatever.
So in this problem, so take a moment, guys. If you haven't looked at 69, look at 69. Take like 30 seconds maybe. Figure out how we write that easier than the addition. Right? The addition's not the easy way. I'm using cards now. Do you know it?
Yeah.
Yeah? Okay, so what do we write for this one?
7 times 5.
I know.
That wasn't fair. Jalen's card was next. Jalen's Yeah, but you can start. So Brandon said, what we do is 7 5 times, right? Or 5 moves of 7. Either way, we get to a length of 35. Questions? Oh yeah, you're next. Don't worry. All right. So, Jalen, this one's going to come to you. Check out 70 with your team. So it says, when adding the same number several times, we're going to multiply. So instead of 4 times 3, so how do we rewrite that? 2 plus 2 plus 2 plus 2 plus 2. Jalen, how do we rewrite that? 2 parentheses 5 or 5 parentheses 2. We have 5 2's being added together, or we have 2 added together 5 times. Either way, what's the total? 10. Like 2 times 5 or 5 times 2, always going to be 10. Now this one's a bit harder because there's decimals involved, so I will actually give you time here. Check out 71. If you get done with 71, go on to 72 and 73. I'm going to capture and then I'm going to scroll my page. But if you get done with 71, move on. So it's pretty much half. That might be worthwhile. So, I will say this more times this year than you care to hear. Break it up. And honestly, once you guys get into like a toxic middle school relationship, I'll tell you break it up too. But with math, if we break things into pieces, right, Mr. Pearson, they get easier. So if we had 3 times, hey, why are people talking? Break it. Don't try to do it all at once. What is 3 times 6? Anyway, 18. Sorry, I don't have a good space to do work. I should really swap screens. Forget this. I'm switching what's on what screen. Don't forget me.
Not you, this is forget you.
Alright, so if you did not write out the work for this, please do so now. If you did not write out the work for this, please do so now. I don't know why my smart board is broken. Well, this failed. Ha! Connecting to the internet used to take at least 30 seconds.
Yeah. That is horrible. But then everybody got
That's
Yeah, right?
It's times that long.
What the heck is wrong with my smart board? Sorry guys, tech issues. Alright, check this out.
I keep stretching when I get a shot.
I said my job is to make your life easier, right?
Yeah.
So if we do 3 times 6.2, and then there's also the plus 2 out there. What we want to do is draw arrows to show what we're doing. So because I don't have space above, because I have stuff written there, 3 times 6, 18. 3 times 2, don't even worry about the decimal right now. What's 3 times 2? 6. Then, how many decimal places should this 6 have? 1, right? Because it had 1 decimal place. So I just give it the 1 decimal place. So this is 18.6. Then we add 2. And we get 20.6. Any questions on how we do that?
Why are we multiplying by 2?
Because there's a 2 right here. Aiden, I'm confused at your question.
I'm confused.
So this tells us, up in the problem, he does.
Oh, never mind. I got it. Thank you. I see, because you have to multiply 3 times.
I'm trying to figure out if it's the noise from the hallway or if people just don't care that like your classmates need help. Hey, people in the hallway! I'm teaching class. Thank you. We really need to help our classmates out. If somebody at your group is talking and they shouldn't be, please correct them politely. Because for some reason, whenever stuff happens in the hallway, it's as if my class doesn't exist anymore. And we're just like here hanging out. So, you're all good here?
I still don't understand.
Don't understand what?
Like, why are we multiplying? Wait, okay. So, it's
Can I act it out for you?
Yeah.
So, I'm Cecil, right? And I guess because the tightrope kind of up there goes left to right. So, I start over here. Right. I go 6.2, 6.2, 6.2, and then 2 more. So 6.2, 6.2, 6.2, I did that 3 times. So we write out 3 moves of 6.2. Now I could add them, right? 6.2 plus 6.2 plus 6.2, 2, 2, 2 makes a 6. 6, 6, 6 makes 18, and I get 18.6. But instead of adding them, we want to multiply to make our life easier. I as soon as I stop talking, you guys stop talking, which is even more annoying. You're talking while I'm talking, just keep talking, because apparently it doesn't matter. So, we break up the multiplication. And instead of trying to do 6.2 times 3, because there's a decimal and it's complicated, I just do 3 times 6 and I get my 18. And then I do 3 times 2/10, but I ignore the fact that it's a decimal for a minute. And I just do 3 times 2 is 6. But it is a decimal, so it needs a decimal place, so I give it 1 decimal place.
Okay. But why are we adding 2?
Because it's the little move at the end. Just because it's up there, it tells us to add 2. After we do the multiplication, we said. Like, that's a separate part of the problem. That is not involved in the multiplication. Because that was throwing you off that, like, that's unrelated.
Yeah.
So, if for your brain you need to, forget about that, we get 18.6. Like, that's the answer to the multiplication, but then we add 2 to it.
So when we do, like, when we're adding something to the decimal point, why do we only add it to, like, the whole number?
Because the amount of value it's been given based off where it stands in the decimal places. So I have that poster up there, which I had to split because where things are up there. But the decimal point gives value, right? So however far you are away on the left makes your value way bigger. However far away you are on the right makes you way smaller. So the fact that the 2 is right beside the decimal, it needs to add with the place that is right beside the decimal, but to the left, and just to the left of it. But when that happens, it actually bumps up and carries over to the next place, the tens place, right? So we add in the ones place, but then it ends up impacting the tens place. But it's all decimal place. Like, it's all where the decimal is. Right, good question. Thank you very much. I guess I can scroll. In 72, how do we rewrite those moves easier? Jalen, did I ever come to you for a question? Ava,
Yeah.
you are the next card after our conversation right there. How do I rewrite what they show me in 72 in an easier manner? Right, my moves that I'm making are -3. Ava?
Okay, so you put a 5 in front of that because you're doing 5 -3 jumps.
Mm-hmm.
And then
How,
wait, don't you need to do 5 times 3?
how far? Yeah, so how far? 15, and then because this is negative,
It's -15.
it's -15.
Oh, that's easy.
So, is there another way? Well, okay, that's kind of a dumb question because we've already talked about that. If we wanted to write this in another way, we could use addition, and we could actually use subtraction. Subtraction's ugly, it's evil, it's bad, it's not real, but you could actually use it. So if we're talking about are there more ways to write this, yeah, we can write it in a lot of different ways. I need to scroll. So math gets real complicated. Yeah, I know we're approaching 9:40. Is that what you're going to tell me? Sorry, what's up?
No, I was curious. Is it possible to multiply a negative by a negative?
Yes. So that would be like, I took on a debt of $5 every week for 10 weeks. But if I go back in time, -10 weeks with my debts of -5, -10 times -5 would be, well, I actually needed like $50 into, it's really weird to conceptualize, but yes, a negative times a negative actually makes a positive, and those rules are up there if you need reminders of that.
Off the negative symbol and then just multiply
Nah,
like
you
that.
can't really just take it off. That's kind of breaking a rule. Apparently my smart software has decided to kick the bucket this morning. So we're gonna write over here. Alright, now I just need you to listen right now. So hear me. Like really hear me. 2 times 3 plus 5. Now, I say that like a robot. 2 times 3 plus 5. Versus, like humans talk, 2 times 3 plus 5. Or 2 times 3 plus 5. Or 2 times 3 plus 5. Or 2 times 3 plus 5. Now this gets real weird because you don't know exactly what I mean. Because where the parentheses fall is determined by your emphasis. No joke. Speaking math makes it complicated. Which is why I tell you guys to write out your work. Because this is 2 times 3 plus 5. This is 2 times 3, plus 5. And then, so it gets real complicated depending on how you say it. These are different, right? So this, and actually this is like the Adrian method from earlier. This is 2 moves of 3 and 5. Right? How far does he go when he does a move of 3 and 5? 8. So what's 2 times 8? So please write down 2 times 3 plus 5 in your notes, but then I'm going to show you another strategy. What's 2 times 3? What's 2 times 5? You've just learned the distributive property.
Wow!
So, I don't have the poster up. Darn, the distributive property poster. So the distributive property, and I'll try to dig it out and hang it up. Yeah. Hey. Distributive property tells you that when you have one number, so I have a lot of posters. I had to pick and choose which ones went up. One number multiplied by multiple things in a parentheses, especially if I cannot add these things together. So let's say B and C could not be added together. Now here we can, but let's say that we couldn't. You just multiply A times your first thing, B here, and then A times your second thing, C here, and carry down the operation in between them. So this, if we rewrite it using the distributive property, 2 times 3 is 6, plus 2 times 5 is 10, and that makes us 16. So please make sure that you have that on your paper, and then we're going to do B, which is different. Solve B on your own, real quick. You don't need very long. Easy math. 2 times 3 plus 5. 2 times 3 plus 5. What's 2 times 3? 6. What's 6 plus 5? 11. So how you say this is going to change your answer. Be careful when you speak math.
6 plus 5 11. Is that how you say it?
Well, yeah, but it's dangerous when you talk about the multiplication. So saying 6 plus 5 is 11, that's not dangerous, because I can pause anywhere in there and it doesn't change anything. But this is 2 times, there's like a pause there, 3 plus 5. This is 2 times 3, there's a pause like here, plus 5.
So like when you have parentheses, that means that you need a pause in your sentence?
Somewhere, yeah, probably.
You're getting a grammar lesson.
Yeah, sorry. So, just like that, and with talking about multiplying negatives, the rule you need to remember is that one negative stays negative, but pairs of negative become positive. Actually, Mr. Smith, if you want to go ahead and pass stuff out, I may just need to keep teaching and just run on through it. So, this is going to stay negative, but break it up. Don't worry about the negative first. So write this out on your paper, please. 3 times negative 2.5 plus negative 4.
Wait, what number is this?
It's number 75.
Okay.
Negative 2.5.
Yes. Because you did it, dude. All right, what's 3 times 2? 6. What's 3 3 times 5? 15. But how many decimal places? 1. So I give it 1 decimal place and it's 1.5. What's 6 and 1.5? But then make it negative. Negative 7.5. Guys, please be with me. I know Mr. Smith's passing back papers. I need you with me, please. So then we add the negative 4. And again, break it up. What's 7 and 4? 11. Then put your 0.5 back on. And if they're both bad, guys, we stay bad. Or we get more bad. Bad or bad? The baddest bad. Evil or bad? Bad or evil? If you're bad or bad, does that mean you're not good at being bad, or does that mean you're really good at being bad?
You're really good at being bad.
So, hey, give me your attention just to drill this and make sure we understand it. Please try these 4 problems, A, B, C, D. It is 77. Care. It is 77. Show the distribution by using those arrows. So when you write out 6 times 12 plus negative 4, we are going to arrow from 6 to 12, either on top or bottom. It doesn't really matter. You with me, Nathan? 6 times 12. And I can kind of in my head break that up if I need to. You might have that one memorized. What's 6 times 10? 60. 6 times 2? 12. Put it together. 72. Then your other arrow. 6 times negative 4.
So 6 times 4 is
Negative 24. So I have 72 plus a negative 24.
which is
Who wins? Good guys, bad guys? Good guys. So I put a plus out here. Then what's the difference? Now this is hard. You might need to stack this. I will not lie to you. This is kind of more difficult because it's going to borrow. So 12 minus 4 is 8. 6 minus 2. Oh, okay. 48. Okay, that works out. Questions on distributing. Now, especially when we have zeros, make your life easier. Forget about the zeros for a moment. Just a moment, though. So what is 7 times 3? I bet most of us know this. 21. Oh, I can't wait for that meme to be 100% dead.
It should be dead.
It's pretty darn close. So, 21, but then how many zeros? 2. 7 times 1. Okay, 7. But 1 more 0, and it's negative. Now, give me one more problem, because I got 2 minutes left. Give me one more problem here. And then we could solve that. It's going to be positive.
It's easy. 1, 2, 3.
All right, check this out. Please write this on your paper.
Mr. Hudson, this makes no sense.
Don't worry, I'll help you. We don't have a ton of time right now, but let's try to AO probably.
Okay.
Hey, peeps that got papers back, put them under your binder right now. Peeps that got papers back, put them under your binder right now, please. We got one more problem to solve. It's not going to help you get a mastery, like, if I skip, like, come on.
Can I see the answer?
Unless you know how to get there now.
I do know how to get there.
How do I break this up and multiply?
Okay. I'll try this. Basically, all you have to do is you just forget the 2 for a second. Basically, you just have to forget the 2 for a second. So what's 4 times 3? 300 is, 12. Well, what's 4 times 3? Is 12. Add on the 0.
Just 1?
2, sorry, 2 zeros.
Ah, 2, because if we just ignore the 2 for a minute, there would be 2 zeros.
4 times 2 equals 8. So, and then exchange, plus 8 equals 1, 2, 0, 12.
There we go. 1208.
1208. Or whatever.
That's how we use the distributive property to make big multiplication attainable. So guys, if you put the actual effort into practicing this now, trust me, it will make your entire math career beyond this easier. I just wish that somebody had showed me this strategy years ago. Have a wonderful day. That's all I got for you.
I got hit by a bus.
Hey, you gotta get out of here. I kept you kind of late. Not like super late, but you gotta go. You guys are awesome, but get out.